Okay, today we're going to continue solving quadratic equations by factorising. You should already have seen part 1 in order to do part 2. These are slightly more difficult, and the difference is that this time there's a coefficient, a number in front of the x squared. All the ones we did in part 1 just started x squareds. All the equations we're going to do today are going to be in this format: ax squared plus bx plus c, where a, b and c are constants. They could be positive or negative. And we're going to solve these, factorise these equations by something that I'm going to call the AC method. And hopefully you'll see why as time goes on. So it's a slightly longer process, and we've got to take it stage by stage. So the first thing we do is we look at this quadratic equation. It's a quadratic because it's got a squared in. It's equal to 0. It must be before we start. And once again, we'll expect two solutions. So the first thing I do is I write down my value of a. So a is the coefficient of x squared. So in this case, it's 6. And c is my constant term. So in this case, it's 2, which would make AC, multiplying them together, 12. Then in this method, what I do is I have to find a factor pair of 12, which sums to the b value, which in this case is 7. So I want two numbers that multiply to make 12 and add to make 7, which in this case is 3 and 4. Sometimes that's easy to find, sometimes it's more difficult. In this case, it's fairly straightforward. What I do then with this 3 and 4 is I rewrite the 7x part as 3x and 4x. You can actually do this either way around. I tend to put the largest ones first. So what I do is I rewrite this quadratic equation as 6x squared, that bit stays the same, plus 4x plus 3x. I get these values from here, plus 2 equals 0. So it's exactly the same quadratic equation. I've just separated this 7x into 4x and 3. My next stage is to factorise these two sections separately. So I'm going to do a partial factorisation by finding the highest common factor. Highest common factor here is 2x. So when I factorise that, I get 3x plus 2. And the whole point in this method is that I end up with a repeated bracket. Well, this one is already 3x plus 2, so I can't actually factorise that. But to make it constant, what I do is I factorise a 1 out, common factor of 1, and so I get that there. What I then do is take these two values here, and that makes my first bracket, 2x plus 1, and my second bracket is this repeated bracket here, 3x plus 2. And what we've got now is we've got to a stage where we had in part 1, where I've got two brackets multiplying to make 0. So what that now means is that 2x plus 1, the first bracket, equals 0, or the second bracket, 3x plus 2, equals 0, and I have two mini equations to solve. So solving this one, 2x would be equal to negative 1, x equals negative a half, and the second one here, 3x equals negative 2, and x equals negative 2/3. So I get my two solutions as expected. They're often fractions when we use this method, and it's best just to leave them as fractions. Example 2, 6x squared plus 11x minus 10 equals 0. Once again, we're going to apply what I'm calling the AC method. So a equals 6, c equals negative 10. Be careful this time, I've got a negative 10 there. So that means my AC equals negative 60. So what I'm looking for now is a factor pair of negative 60, which sums, adds up to this b value here, which is 11. So I'm looking for a factor pair of negative 60, which sums to 11. Now this might take you some time to work out. I've already worked this out, and it turns out that the factor pair is positive 15 and negative 4, because positive 15 times negative 4 will give you negative 60. When you add them together, it gives you 11. So I'm going to rewrite this quadratic here, 6x squared plus 15x minus 4x minus 10 equals 0. So these two parts here come from what I did here in the AC method, and that's just exactly the same as 11x. So I'm now going to partially factorise these two sections here. 6x squared plus 15x, the highest common factor here is 3x. So I'm left with 2x plus 5. And if this has worked out correctly, my second bracket also should be 2x plus 5. So what did I have to factorise out of there? That would be negative 2. That's the factor I've taken out. I take these two at the front here to create my first bracket, 3x minus 2. The second bracket is my repeated bracket there, equals 0. So I've now successfully factorised, and I use this factorisation to solve the equation. 3x minus 2 equals 0, or 2x plus 5 equals 0. Those are the two brackets. One of them must be 0 to make the product 0. So solving this mini equation first, 3x equals 2, so x equals 2/3. On the second one here, 2x equals negative 5, x equals negative 5/2. Once again, I've got fractions. This one's an improper fraction, but it's best to leave it in fractions and leave it as an improper fraction.